Okay. The next question that we have to see is the book back question in aniline chapter 13.3, fourth subdivision. Although amino group, what is amino group? NH2 group is orthopara directing in aromatic electrophilic substitution. What are they meaning? Which aromatic amine we know? Aniline. When you take aniline, the NH2 group releases electrons into the ring. Is it not? So we know that due to resonance, with respect to NH2 group in aniline, the ortho and para positions will become electron rich. Charge becoming bond, bond becoming charge. So this position becomes negatively charged. So in the next resonance structure, this moves here, this moves here. So what do we get? Double bond NH2 plus. In the next resonance structure, this moves here, this moves here. Charge becoming bond, bond becoming charge here. So in the next resonance structure, charge becoming bond, bond becoming charge. The electron density is restored like this. So what do you understand here? Due to resonance, the ortho and the para positions are made. See, this position is ortho with respect to NH2 group. This position is para with respect to NH2 group. And again, this position is ortho with respect to NH2 group. Ortho positions, we have two ortho positions and one para position, right? And due to the richness of electron density, we say it is ortho-para directing. Okay, but only in nitration, that is the second part of the question. Only in nitration reaction of aniline, we get meta product also. Ample quantity of meta product is also given. They are asking what is the reason. See, we know that nitric acid is a strong acid. And in the nitration, during nitration reaction, we use a mixture of acids, concentrated nitric acid and concentrated sulfuric acid. So these acids will produce H plus ions, no, in aqueous medium. And this H plus ions is the acidic H plus ion goes and forms coordinate bond with the, see, amines we know they are basic. So the lone pair gets protonated, resulting in the formation of aniline with the H plus ion liberated by the acids in the medium. It produces anilinium ion. What is anilinium ion? C6H5 NH3 plus. So when you have some 100 molecules, just imagine that you are having 100 molecules of aniline. Out of those 100 molecules, a part, and it is observed that almost 50%, near to 50% means what? 100 molecules, if we have 50 molecules become converted into anilinium ion. The remaining 15 molecules, they exist as aniline. So what happens? These 50 molecules will form ortho on nitration. Nitration means what? When these two react, they will produce nitronium ion. So when aniline reacts, a part of the aniline molecules which exist as aniline, they react with the nitric acid, nitration mixture we call it, which produces nitronium ion, and this NO2 plus gets attached to ortho position. That is one product. See, always electron releasing groups will give a mixture of two products, ortho product and para product. But there is also a definite amount of these molecules, these ions in solution. And this anilinium ion is an electron withdrawing group. Why electron withdrawing group? It is not having any lone pair on nitrogen. So what happens? It has a positive charge rather. So what it does? It starts pulling electrons from the ring. So what it does, instead of releasing electrons, it withdraws electrons, and withdrawing also is more powerful from ortho and para positions. So in anilinium ion, what happens? The ortho positions are positively charged. In an aniline, we saw that ortho positions are negatively charged. No, they get a greater electron density. But in anilinium ion, ortho positions are getting positive charges because of lesser electron density. So when compared to ortho and para, meta is relatively electron rich. So this anilinium ions present in solution, when they undergo nitration reaction, they will form only meta product. So after that, when you hydrolyze this anilinium ion will again become the anilinium ion formed when you just treat it with a base. It will give out the free aniline. So the final product, nitration followed by reaction with base, mild base, dilute NaOH. It will liberate the free NH2. So what will you get? We will get a sumptuous amount of meta product also. So we are getting around 49% of meta product, and ortho will be got in smaller quantities only because of steric hindrance. Already there is a bulk, this occupies some space. So the nitro group will avoid mostly ortho position. And that too, if since meta is also formed, ortho is totally reduced. Only 2% of ortho we get, and para we get around 51%. So we get nearly same quantity, nearly equal proportion of para and meta. And the formation of meta is due to the formation of anilinium ion in solution because of the presence of mixture of acids. Clear? So this is how we have to explain. Understood? Write down the points.